Now let's move to the truth values for the premises and the conclusion, constructing one column at a time. We'll draw the values for the premises components from the left-hand side of the table and then apply the rules for truth functional connectives in each of the columns. Beneath the first premise, we'll have this column. Note that the premise is an either-or statement, so we'll have to apply the rule for disjunction, which states that disjunctive statements are false if and only if all the component disjuncts are false. Otherwise, disjunctive statements are true. As you can see, in the first row, both B is true and C is true, so the disjunction of B or C is true. In row 2, B is true, so the disjunction is true. In row 3, C is true, so the disjunction is true. But in row 4, neither B nor C is true, so the disjunction is false. Now let's do the next column beneath the second premise. This one's easy. We just take the values from B on the left-hand side and put them in. Now we're ready for the conclusions column. The conclusion is a negation that reads tilde C or not C. So we have to apply the rule for negation. A statement and its negation always have the opposite truth value. So we take the values underneath C on the left-hand side of the table and negate them in the column for the conclusion. Let's review what we've just done. You'll note that we now have truth values for each premise and the conclusion based upon each combination of component simple propositions. As we've just explained, the first premise is a disjunction, so the column beneath it will be determined by the rule for disjunction. The first column on the right, placed under the wedge, shows the result of this calculation. Since the second premise, B, is a simple proposition, we can't calculate its values by using any of the truth value rules for connectives since it doesn't contain any. So we assign to B the same values that it has in the first column on the left-hand side of the table. That is, we simply transfer those values to the second column on the right-hand side of the table. We now calculate the truth value of tilde C by applying the truth value rule for negation to the values of C, which are displayed in the second column on the left. We write down the results of this calculation under the tilde, as shown by the truth table's third column on the right. To check the validity of this argument, we can scan each row, looking for a row where the premises are all true and the conclusion false. This row has true premises and a false conclusion. This row has all true premises. This row has one false premise and a false conclusion. And the last row has two false premises and a true conclusion. The important thing to recognize is that we have found in this truth table a row where all the premises are true and the conclusion is false. This shows the argument to be invalid because we've shown that it's possible for the premises to be true and the conclusion false at the same time. Get the idea?